Hello everyone, welcome back. Today we are going to solve another problem of Leetcode. So the problem name is best time to buy and sell stocks. So this problem is similar to the one that we had solved in the previous video. So it's just a basic enhancement of that problem. So let's go through the problem once. Here you are given an integer array prices where prices of I is the price of a given stock on the ith day, right? On each day you may decide to buy or sell the stock. You can only hold at most one share of stock at any time. However, you can buy it and then immediately sell it on the same day. Okay, we have to find and return the maximum profit you can achieve. Okay, so the enhancement in this question compared to the previous one was that in the previous problem we could only buy and sell the stock only once in the entire array, but here we can buy a stock and then sell a stock, then again buy it if we get a better price. So this is the given array 715364. So what here we are trying to explain is, so let me draw this array 71564. We can buy a stock, then sell a stock, then again buy this stock and then sell this stock. And we can keep on iterating over this basically loop, right? Also, one condition that we need to take care is that at any particular point of time we can't hold two stocks. So that is mentioned over here. You can hold at most only one share of the stock at any time. So it means that we can't do this. We can buy a stock then again buy it. This condition is wrong. So suppose we bought a stock at a price of 7, we cannot buy a stock again at a price of 1. We need to sell the previous stock before we buy another one. So the approach for this problem as well remains the same that was used for the previous problem. So what we need to do here is we need to maintain two variables that we had also considered in the previous problem. So one variable is called min, which is used to denote the price of the stock at which we are buying, buy price. So initially this buy price would be initialized to the first element of the array, which is 7 in this case. It means that we are kind of buying the stock at a price 7. And there is another variable called profit, which can initialize it to 0, that we haven't made any profit as of now. What we will do now is we will iterate over this array. So next element what we have found is it is 1. So we compare 1 with 7, which means instead of buying the stock at a price of 7, we should buy it at price 1. So 1 is less than 7, so we update this min variable as 1. So it means that we are buying the stock at a price 1 instead of 7. Now we go to this index, which has a value of 5. It is greater than min value, which means that we can sell the stock at a price of 5, right? So in this case we would have earned some profit. So the profit would be the current value of the stock, which is 5, minus the min value, which is 1. So the profit would be 4. And in this case what we will do is we will also update the min value from 1 to 5. Why are we updating it in this case? Why are we updating the min value is in this case as well? Because suppose we bought the stock at 1, then sold the stock at price of 5, then we can buy the stock again at a price of 5 as well, right? We bought at 1, then sold at 5, then we again kind of bought the stock at a price of 5. Now we go to this index 6. We observe that 6 is greater than 5, which means we can sell the stock at a price of 6. So the profit would be the current value of the stock minus the minimum value, which is 5. So it will be 1. Now we also in this case as well we update the min value. Now it will be 6. Now we come to this 4. So 4 is less than 6. So we update this min value as 4. And the profit value, overall profit value would be the cumulative sum that have been done till now. It will be 4 plus 1 would be 5. Let's take another example, 7153. So this example, let's take 715364. 715364. Right, so here we will also maintain two variables. Min will be initialized to 7. Let me change the color. Min will be initialized to 7. Profit would be initialized to 0. Now we come to this index. The value is less than min, so it is updated as 1. Now we come to 5. It means that we can sell the stock at a price of 5. So the profit would be the current stock price, which is 5, minus min value. Min value denotes the price at which we have bought the stock. It means we have bought the stock at a price of 1. So 5 minus 1 is 4. Now we come to this 3. Also we had updated the value from 1 to 5 in that case. Now we come to 3. So 3 is less than 5. So this value is updated as 3. Now we come to 6. 6 is greater than min value. So we can sell the stock at a price of 6. So the profit would be 6 minus the price at which we buy the stock, which is the min variable value, which is 3. So 6 minus 3 is 3. Also we update the min value as 6. It means that when we sold the stock at a price of 6, we also bought the stock at a price of 6. Now we come to this index 4. So we check 6 is greater than 4. So we update this min value as 4. So the answer would be, in this case, would be 7. So overall in this case, at what all prices we are buying and what all prices we are selling. So we bought the stock at a price of 1, we sold it at a price of 5. So this was one buy sell sub loop kind of thing. Then we again bought the stock at a price of 3 and sold it at a price of 6. So this was one buy and sell loop, right? So here we are doing purchase and selling 2 times. In the previous example that we had discussed, this one could argue that, like, we can argue that why are we buying and selling it 2 times? Like here I had told that I am buying the stock at price of 1, then selling it at 5, then I am again buying the stock at a price of 5 and then again selling it as a price of 6, right? So here the profit was 4, here the profit was 1, so I'm taking a sum of them as 5. So I was kind of buying the stock 2 times. So instead of buying the stock 2 times, what I could have done is I could have bought the stock at a price of 1, and whenever the price of the stock is increasing, so it is increasing sequence, right? So 1, 5, 6. So I shouldn't have sold the stock at a price of 5. So I bought the stock at a price of 1. I don't sell the stock at a price of 5. Instead, I keep that stock with me, and when the price was 6, I sell that stock. So basically the difference would be 6 minus 1 would be 5. So answer in both the cases would be same, but also the implementation would be much similar. Like in this case I have to maintain a loop which tells me that like the sequence is monotonously increasing, and what is the index at which I don't have to sell that stock. But this approach looks much simpler to me, that whenever the selling price is greater than the buying price, I just sell it without thinking anything. And whenever I sell that stock, I also buy the stock at that particular price. So that in that way the implementation is much simpler. The complexity wise for this algorithm is, like, we are iterating over this array only once, so the time complexity would definitely be of n. And the space complexity wise, we are simply using 2 variables, min and profit. So space complexity would be of 1. Right? If we jump to the coding part, yeah, so here I have written this code already. So the code is very much similar to the solution for this problem, best time to buy and sell stock, in which we were allowed to buy and sell only once. So solution is very much similar. So we are initializing the min value as the first value of the array and starting the loop with the first index till the last index of the array. And if the current index value is less than the minimum, I am updating the min value, right? And if it is not the case, it means I have to sell the stock. So in that case, I am taking a cumulative sum of the previous profit that have been accumulated till this point of time and the current profit, which is current stock price minus min value. And the min value at this point would have the value at which I had bought the stock. And also I am updating the min value as the current stock price. So it means that I am buying the stock as well whenever I am selling it, right? And in the end I am just returning profit. So if I run this code, yeah, so solution runtime and memory usage are both are fine, and obviously it has to be fine because we are running the code in O and time complexity, and the space complexity is also O1. Right, so there are similar problems that have been attached in the similar questions section, which are of hard level, I guess. Yeah, hard and medium level. So just try these problems out, and if you have any questions, so please ping in the comment section of this video, or you can ping me in any of the social media platforms. And yeah, that's it for now. And if you haven't subscribed to the channel, please do consider it. And I will see you next time with another interesting problem of Leetcode. Thank you, everyone.